Good morning, class. We're going to start with some earth science this morning. Let's do lesson number 13, and we're going to cover recent changes in Earth's climate. So we just finished up looking at the history of climate change. On Earth, we focused on kind of the major changes in Earth's climate throughout its history. There's a lot that we kind of skipped through, um, just so we can spend a bit more time focusing on nowadays, like today, recent history. So I first want to look at how long have humans or our ancestors been affecting the climate? Initially, I thought it'd be pretty recent that we really started to affect the climate, but when we look a bit deeper, it actually goes back to about 1.2 million years ago when fire first started to be used as a regular tool. So when you burn something, you're actually emitting greenhouse gases into the atmosphere. So even though the impact would be very small, because the population of our ancestors was tiny at this point compared to now, we still had some impact on the climate by using fire. And then if we jump forward to 7,000 years ago, so in that period of time, we only really had fire to affect the climate. But around 7,000 years ago, we started to depend on farming and agriculture, along with livestock, to survive. So we started to control the way the land looked by farming on it. We started to control how animals moved by having livestock. And this had impact on the climate as well. And along with um, the agriculture, when our population started to increase, so about 2,000 years ago, we started to go through a phase where we removed a bunch of the forests in Europe. So the population started rising, and we needed more farmland. So we started to destroy the forest in Europe. And by about 4,000 years ago, by the 1600s, there's only about 10% of European forests remained. So even before um, we started really getting into the industrial age, the forests in Europe were wiped out. 90% of them gone. So humans have had a long history of impacting climate and changing the way the Earth looks, even before we had all this new technology. So this changed the makeup of the atmosphere. Greenhouse gases started to rise, started to increase. There's more of them. And if we look at the data on the left here, it shows us how humans have changed the actual makeup of our atmosphere pretty drastically. So right now, we are currently in the, I'd say, early to middle ranges of an interglacial period. So it's been about 15 to 20,000 years we've been in this interglacial period. And what this data does is it looked at past interglacial periods and how the atmosphere has changed at about 15 to 20,000 years into an interglacial period. So that's where we are nowadays. And it modeled that against what we see today and what we see in the past on how the atmosphere actually looks 5,000, 10,000 years ago compared to what it's supposed to look like. So the blue lines, that's your natural trend. That's what the atmosphere is generally looking like during these interglacial periods. And we can see that our current interglacial period followed it to about 6,000 to 400,000, or 4,000, not 400,000, 4,000 years. And then we caused a drastic change. It's a very unnatural change. So it's not like, oh, we're off by a little bit. It's a sharp change where the CO2 levels in the atmosphere and the CH4 levels in the atmosphere started to increase. So these are both greenhouse gases. CO2 is just a more common greenhouse gas. So we can see that humans have had a huge impact on the way the atmosphere is made up. Now, that's not to say the atmosphere has never looked like this before, because there has been periods where it has, but in the past millions of years, the atmosphere has not looked like this, and it's only because humans have impacted it that it looks like this. So just to kind of give you a sense of what the graph's looking at, when we look at the carbon, or the CO2, we see that it's in units of parts per million. That's the ppm. So if you had 1,000,000 particles, and let's say if we look at, and we have 260 parts per million, out of those 2,000,000 particles, 260 of those particles are going to be CO2. Now with the CH4, it's a lot less. So we have parts per billion, so ppb. So per 1,000,000,000 particles, we're only going to have around 650 of these CH4 particles. So it's not like there's just only CO2, but because CO2 is a very efficient greenhouse gas that traps a lot of energy, small changes can have a drastic impact on the climate. So this data is really focusing on the 10,000 years ago to kind of recent to now, to like maybe 100 years ago. It doesn't actually show the sharp increase that we see in the last 50 years. So it's not accurate for analyzing the effect we're having on the atmosphere now, but it shows that the history of how humans have affected the climate. So we'll get more into recent time in a bit here. So as the human population has increased and our technology has increased, we're seeing a dramatic shift in the makeup of the atmosphere, as well as how rapid the climate is changing. So if we look at the data on the left again, we can see a very dramatic change of course. So it's following the natural trend, and then all of a sudden it's a sharp change. And the change we're seeing in the last 50 years is even sharper. It's a lot more drastic, which is the cause for concern, is that we're changing it so much and so fast that it's going to be hard to recover from. But we are slowly, very slowly realizing the impact we're having and how harmful this is. So we are taking baby steps to reduce the impact. So in the last couple of years, there has been progress made, but because the impact jumped up so fast, we need to do a lot more than what we're doing. And we'll talk about that in future lessons. So looking at these two graphs here, the graph on the left, this shows the average temperature on Earth compared to the average temperature in 1951 to 1980. So they just took all that data, they averaged it to one number, and we're going to call that 0. So that number is about 12.5 degrees Celsius on average. So back in 1860, we were actually just coming out of like a mini ice age. So the temperature was cooler than it is today, but we can see it quickly increases as humans have affected the climate. And we get all the way up to about now, we're about 1 degree Celsius warmer than we were from the 1950s to the 1980s, which is a large change. So 1 degree Celsius might not seem like a lot, but for that change to happen in 40 years is very quick compared to in the history of Earth, where we have, let's say we're going to increase by 1 degree, it's going to take 100,000 years, maybe even 1,000,000 years to have that big change, unless we have a supervolcano or a meteor hit. So we can think of our impact on the climate to be similar to being like a supervolcano going off or a meteor hitting Earth, which is crazy because those are devastating natural events. Saying that we're doing the same thing is mind-blowing sometimes. Okay, so that's the data on the left. The data on the right, I wanted to put that in there just to show you like really how sharp the increase is. So this goes back to the year 0. I guess if there is, yeah, year 0, they just didn't call it that back then. And it has the same average data. So it's averaging the data from 1950 to 1980. So it just shows how over time Earth's temperature has slowly changed, but all of a sudden it just drastically jumped up. So the black line is the predicted values, and those gray lines, like light gray lines, those are kind of the error. So it could be up as that high or it could be as low as that. So let's say if we look at 1,000 years ago, it could be as high as half a degree warmer, or it could be maybe 0.2 degrees less than average. But on average, it's going to be about maybe 0.2 degrees more. So those are kind of just the error bars. So it's really drastically, we have increased the temperature on Earth. again, the quickness of that's the scary part, is how quick we're changing. So it's not only that we are affecting how the temperature is changing on Earth. So it's not only that we're increasing the temperature of Earth, we're also changing the volatility of the temperature on Earth. So we're setting record highs and record lows in the same year. So for temperature wise, so there's places on Earth that have record high temperatures, and there's also places on Earth that have record low temperatures. That's because all the pollution we're putting in the atmosphere, all the greenhouse gases we're putting into the atmosphere, and all the other effects we're having cause not only warm spots, but cold spots. So there's a lot of volatility in Earth's temperature, which is the one thing that humans don't like. For any species, really, we want a consistent temperature so that we can live consistently throughout the year. So having that volatility is also a scary part of climate change. And this volatility kind of comes with oceans warming. So not only are we warming up Earth's atmosphere, we're also warming up the oceans. When we have warmer oceans, we also get more volatile winds. So we can have winds that go from nothing to being very quick, over 100 kilometers an hour winds really quickly because of these warming oceans. So if we look at the data on the left, there's the power displacement index. And what that is that just a measure of the activity of cyclones. So cyclones, you can think of as tropical storms. So not quite hurricanes, but just where we have extreme winds. And this kind of takes all the factors, strength, duration, and frequency of tropical storms and puts them into one number. So we can kind of track how many storms we're having, how strong they are, and how long they're lasting, all is kind of one number. And we can see that it correlates very closely to ocean temperatures. So we saw in the last couple years, we've actually had, or when the data ended, we had less cyclone activity, but it's actually picked up now. I just couldn't find any recent data on it, but it's picked back up again. So as the sea temperature warms, so does dangerous winds. So we're also getting more hurricanes as well, which is something that, again, natural disasters is not what we want. It's not good for humans, it's not good for animals, it's really not good for anybody. So warmer ocean temperatures means more volatile winds as well. The other effect that we're having when we're warming the ocean is that the ocean currents are changing. So the warmer the oceans are, the slower their currents move, and the currents are actually changing course. So we're getting less ocean currents from the poles down to the equator. And what this means is we can see where there's not good water movement, where there's not strong currents, we can see very drastic temperatures pop up. So it's predicted if the ocean temperatures keep getting warmer around Europe, so around Spain and Portugal, the coastal cities in Europe, maybe even Italy as well, the ocean currents would drop off significantly, and that would give drastic temperatures in those countries where you see the temperature rise up to 10 degrees Celsius because we're not getting cold water move into the area. So the water just keeps warming up and warming up. So to summarize, the effect that we're having on the climate is we're warming the temperature, we're adding volatility to our temperature, so we're getting big highs, big lows, we're increasing the volatility of winds, we're changing the ocean currents, and all this is just going to compound into warmer temperatures, harsher environments for us, and less stable life in general. So life will just be less stable the more climate change increases. So next class, we're going to start talking about what is causing these. So I've given you kind of what's happening, and then we're going to look at what is causing them. Secret word for today is going to be TV. I hope you all have a great day. Try to answer the questions. I think I'm just going to give you like 4 questions. Won't be too much. I gave you a long problem set last class. And hope you have a good weekend.